Good day, everyone. Now we will discuss handout number 4, the continuous probability distribution. But before anything else, I would like to introduce myself. I am Julian Rose Redoble Legaspi, and I am with my co-members, Divine Grace Kalibugan, Raj Ruben Lumod, Ahalia Rose Matuod, Halil Mission, and Dines Hatero. And this is the Group 1 from BSME 2C. Here are the learning objectives in this topic. First, we will going to determine the probabilities from the probability density function. Second, determine probabilities from cumulative distribution functions and cumulative distribution function from probability density function and the reverse. Calculate means and variances for continuous random variables. Then select an appropriate continuous probability distribution to calculate probabilities in specific applications. Lastly, calculate the probabilities, determine means and variances for each of the continuous probability distribution presented. And these are the content outline. First, we have the continuous random variable. A continuous random variable has two main characteristics. First, the set of its possible values is uncountable. And we compute the probability that its value will belong to a given interval by integrating a function called the probability density function. For example, the height of students in a class. The heights of students are measured in either feet or centimeters. These measurement units have a decimal or fractional value also. Hence, the variable can take any real number, so it is a continuous data. 2. The change in temperature throughout a day. For example, let's say you were trying to measure the temperature of a room. The temperature could be 74 degrees or 74.1, 74.11 or 74.112, etc. This is because the temperature can occupy any number on your scale of measurement. This means that it is also an example of continuous data. Number 3, the number of hours a person works in a week all contain a range of values in an interval. The variable time ranges over the entire real number line or depending on the context over some subset of it such as the non-negative reals. Thus, time is viewed as a continuous variable. Because the number of possible values of a random variable example x is uncountably infinite, then x has a distinctly different distribution from the discrete random variables. The range of x includes all values in an interval of a real numbers. That is, the range of x can be thought of as a continuum. A number of continuous distributions frequently arise in applications. These distributions are described and given example of computations of probabilities, means, and variances are provided in the remaining sections. The probability density function, are also known as PDF, defines the probability function representing the density of a continuous random variable lying between a specific range of values. In other words, the probability density function produces the likelihood of values of the continuous random variable. Sometimes, it is also called a probability distribution function or just a probability function. However, this function is stated in many other sources as the function over a broad set of values. Often, it is referred to as cumulative distribution function or sometimes as probability mass function, also known as PMF. However, the actual truth is PDF, or also known as probability density function, is defined for continuous random variables, whereas PMF, or probability mass function, is defined for discrete random variables. For a continuous random variable x, a probability density function is a function such that probability of x is greater than or less than equal to a, but lesser than or equal to b, equals the integral of a to b fx dx, equals area under fx from a and b for any a and b. fx is greater than or equal to 0, and fx is negative infinity to positive infinity. Fx dx is equal to 1. Probability density function provides a simple description of the probabilities associated with a random variable, as long as fx is non-negative and so that the probabilities are properly restricted. A probability density function is 0 for x values that cannot occur, and it is assumed to be 0 wherever it is not specifically defined. Take note that if x is a continuous random variable for any x sub 1 and x sub 2, the probability of x is greater than or equal to x sub 1 but lesser than or equal to x sub 2 is equivalent to probability of x greater than x sub 1 but lesser than or equal to x sub 2 is equivalent to probabilities of x greater than or equal to x sub 1 but less than x sub 2 is also equivalent to probabilities of x is greater than x sub 1 but less than x sub 2. Example number 1. Let the continuous random variable of x denote the current measured in a thin copper wire in milliamperes. Assume that the range of x is 0 and 20 milliamperes. And assume that probability density function of x is 0.05, for 0 is greater than or equal to x but less than 20. What is the probability that a current measurement is less than 10 milliamperes? The probability density function is shown in figure 1 as you can see here in the graph. It is assumed that fx is equal to 0 wherever it is not specifically defined. Probability requested is indicated by the shaded area in the figure. So as you can see, probability x is equal to 10, which is equal to integral of 0 to 10. Fx dx is equal to integral of 0 to 10. 0.05 dx is equal to 0.5. Another example is the probability of x greater than 5 but less than 20 is equals to integral of 5 to 20. Fx dx is equal to 0.75. Example number 2. Let the continuous random variable x denote the diameter of a hole drilled in a sheet metal component. The target diameter is 12.5 millimeters. Most random disturbances to the process result in a larger diameter. Historical data show that the distribution of x can be modeled by a probability density function, which is equals to 20 e to the power of negative 20 quantities x minus 12.5, which is your x is greater than or equal to 12.5. If a part with a diameter larger than 12.60 millimeters is scrapped, what proportion of part is scrapped? The density function and the requested probability are shown in figure number 2. A part is scrapped if x is greater than or equal to 12.60. Now, so as you can see, the probability of x is greater than 12.60 is equal to integral of 12.6 to infinity fx dx, which is our value of fx is 20 e to the power of 20 quantities of x minus 12.5 is equivalent to 0.135. What proportion of parts is between 12.5 and 12.6 millimeters? Now, our x is greater than 12.5 but less than 12.60, then it's equals to integral 12.5 to 12.60 fx dx. Again, our value of fx is 20 e to power of negative 20 quantities x minus 12.5 is equals to 0.865. Because the total area under of fx equals 1, we can also calculate that the probability of x greater than 12.5 but less than 12.60 is equal to 1 minus probability of x greater than 12.6 is equivalent 1 minus probability of x greater than 12.6. 1 minus 0.135 sa atong nakuha ganina given, and then equals to 0.865. As you can see, they are just the same answer. Now, let us go on to cumulative distribution function. An alternative method to describe the distribution of a discrete random variable can also be used for continuous random variables. The cumulative distribution function of a continuous random variable, capital X, is fx is equal to p, which is capital letter X, is less than or equal to x, equals to integral of negative infinity to x, which is fu du for negative infinity is greater than x but less than positive infinity. Extending the definition of fx to the entire real line enables us to define the cumulative distribution function for all real numbers. The following example illustrates the definition. So we have the example. For the copper current measurement in example 1, the cumulative distribution function of a random variable x consists of three expressions. If x is greater than 0, then fx is equals to 0. Therefore, if fx is equal to 0, for x is greater than 0. And fx is equals to integral of 0 to x. Fu du is equivalent to 0.05 dx. For 0 is less than or equal to x, but x is less than 20. Finally, integral to 0 to x, fu du is equivalent to 1, for 20 is less than or equal to x. Therefore, fx is equals to 0, x less than 0, 0.05, where x is greater than or equal to 0, but less than or equal to 20. 1, which is 20, is less than or equal to x. Notice that the definition of fx can be changed to and vice versa. That is, fx can be defined as either 0.05x or 0 at the end point. In other words, fx is continuous function. For a discrete random variable, fx is not continuous function. Sometimes, a continuous random variable is defined as one that has a continuous cumulative distribution function. The probability density function of a continuous random variable can be determined from the cumulative distribution function by differentiating. Recall the fundamental theorem of calculus states that differentiating integral of negative 8 to x fu du with respect to x is equal to fx. Then given fx is equal to derivative of fx with respect to x, as long as the derivative exists. Example, the time until a chemical reaction is complete in milliseconds is approximated by the cumulative distribution function. Fx is equal to 0, where x is less than to 0, 1 minus e to the power of negative 0.01x, where 0 is less than or equal to x. Determine the probability density function of x. What proportion of reaction is complete within 200 milliseconds? Using the result that the probability density function is the derivative of fx, we obtain that fx is equal to 0, where x is less than to 0, 0.01 e to the power of negative 0.01, where 0 is less than or equal to x. The probability that a reaction completes within 200 milliseconds is equals to 1 minus e to the power of negative 2 equals to 0.8647. The next topic is the mean and the variance of a continuous random variable. It will discussed by Raj Ruben Lumut.
Now, let us talk about mean and variance of a continuous random variable. The mean and variance of a continuous random variable can be determined with the help of the probability density function or your f of x. So, makuha na to ang mean and variance of a continuous random variable through your probability density function. And your probability density function or your PDF is already given in the problem. So now, let us tackle the mean of continuous random variable first. So the mean of a continuous random variable can be defined as the weighted average value of the random variable x. It is also known as the expectation of the continuous random variable. So simply, your mean is the expected value or the expected value of your continuous random variable. So now, we have this formula. So capital E of x is kana equals to the mu, since mu is kana na mo ang symbol sa mean, di ba? Tapos equals rin ng mean o expected value. So pwede rin na. So again, capital E of x is equals to the integral of x f of x dx, where E of x or the expected value or your mean, then x or the continuous x for the continuous random variable, note ha nga capital X ni siya. Then f of x is equals to the your probability density function. The formula for the expected value of a continuous random variable is the continuous analog of the expected value of a discrete random variable, where instead of summing over all possible values, we integrate. So as what Ms. Legaspi stated earlier, that sa discrete random variable, you just have to sum up all the given values to find your mean or your expected value, because discrete random variable is a finite value or kanang maihapra bitaw, whereas ang continuous random variable is infinite value or kanang dili siya maihapra sa atong kamot kay naa siya decimal. So kanang simply murag na siya kanang it should be measured like the imuhang ato ang temperature sa ato ang kanang distance, pwede ang distance, then atong weight namo gyud na siya sobra, dili gyud na siya like sakto-sakto ang ato ang value para ana. So kanang kinahanglan ta mo use sa integration kay dako naman or daghan na siya kanang nanay mga decimal lang atong values nga given. So now let us talk also about the variance of continuous random variable. So the variance of a continuous random variable can be defined as the expectation of the squared differences from the mean. So it helps to determine the dispersion in the distribution of the continuous random variable with respect to the mean. So let me tell you about a little about variance. So variance is a measure of how data points differ from the mean. So in layman's term, variance is a measure of how far a set of data or numbers are spread from their mean or the average value. So we also have a formula for the variance. So ang formula sa variance is sigma squared equals to the integral of x squared f of x dx minus your mean squared. So no, where sigma squared mo na ang symbol sa tong variance, sigma squared. Or pwede sad guys o var VAR, capital VAR of x. Pwede rin na siya. Pero natay simple lang sigma squared. Sigma squared is equals to variance. And x squared or the squared value of your continuous random variable. So ang difference niya ani sa ato ang kanang formula sa expected mean, expected value or the mean is kanang atong continuous random variable, constant naman na siya no. Ang continuous random variable x na to is ato ang butangan og squared. Then f of x, or the probability density function, and mu squared, or your expected value squared, or the squared value of expected value. Sorry. Mo to ang formula sa ato ang kanang variance is kanang uh, murag formula sa atong expected value, pero mag-minus ta sa atong nakuha nga expected value katong naay mu squared, pero nya atong is squared. So as what you can see in the presentation, mo na siya ang formula sa atong variance. And also sa we also need to find the standard deviation, and to find the standard deviation we have to find the square root of the acquired value of the variance. So in the variance of a continuous random variable, the definition is the same and we can still use the alternative formula. Given only we now integrate to calculate the value. So mula gina sa pag-find nato sa continuous random variable, we are involving integration para makuha nato ang value nato, mga value nato. Now, let us proceed to the example 1. So, the time in seconds it takes to reheat a cup of coffee can be modeled by the continuous random variable x with probability density function f of x is equals to 38x squared, where x is greater than or equal to 0 but lesser than or equal to 2 and 0 elsewhere. Now, let us calculate the expected value of time it takes to reheat a cup of coffee. So, using the formula for the expected value, capital E of x is equals to the integral of x, f of x dx, from negative infinity to positive infinity. So, ato nang input, ato mga data, no? So, sa ato 38x squared, so ato ko nung x kay greater than 0, or muna to ibutang sa ato ang lower limit, then ang ato ang lesser than or equal to 2, so muna ato ang upper limit, then x times your probability density function 38x squared dx. So kung iimo na siyang i-input sa imong calculator, you will get a value of 1.5 for your expected value. So 1.5 seconds kay nanguha man ta nag-calculate man ta sa expected value of time. So this only tells us what we could expect the average or mean value of continuous random variable to be after a sufficiently large number of trials. Given this scenario, the scenario where we are reheating the cup of coffee, what this tells us that if we are to make a note of the time that it takes to reheat a cup of coffee 100 times, 1,000 times, or even for 1,000,000 times, then the average of all the times that we have written down will tend towards 1.5 seconds. So, bisan pagkapila nimo siya initon, so padung ra gyapon na siya sa 1.5 seconds nga expected value. Now, we calculate the variance and the standard deviation of x by first finding the expected value of x squared. So, kanang dili man nimo makuha ang imuhang variance kung dili nimo square ang imuhang continuous random variable. And also, di po di mo makuha ang imong standard deviation without finding for the variance. Now, let's use the formula for the variance. So, the sigma squared is equals to the integral of x squared times your f of x dx from negative infinity to positive infinity. So naman tay given, no, mura gihapon you will input the values sa imuhang kuan, then mag-add lang ka, mag-minus lang ka, no, di ba, as what I have said ganiha nga ang formula sa to ang variance is just murag same ra gyud na siya sa imong expected value. Magdugang lang kag kanang na minus imong makuha nga value sa imuhang expected value. Imo siyang i-squared. So since nakakuha man ta og kanang naay 1.5 seconds, so in fraction it's 3 half mo na siya nga 3 half square basig matingamo ba nga y kanang 3 half dili 1.5, so pwede ra gyapon 1.5 inyong gamiton pero 3 half lang akong gigamit kay wala 3 half lang. So kung ato na siyang katang i-find ato na input sa to calculator, then we could get a answer of 3/20 or 0.15 for our variance. So that is our variance for the example number 1, 0.15. So to get the standard deviation, simply you just have to find the square root of 0.15, and that is 0.387. So muna na imong standard deviation for your example number 1. So ingana ra siya ka kanang not so complicated. You just have to remember the formula correctly para dili ka masayop. Now let us go on to the example number 2. Find the mean of the time of a person waits for an elevator to arrive. The PDF of x was given by f of x is equals to x, where x is greater than or equal to 0 but lesser than or equal to 1. Also, 2 minus x, where your x is greater than 1 or greater or equal than 1 or lesser than or equal to 2 and 0 otherwise. So, solution. So, use the formula for the expected value. E of x is equals to the integral of x times your f of x dx. So, ato rang i-input ta ng data nato, no? Then, kani nakalahi lang ani sa example number 1 is ang ato ang probability density function is duha ra to katong 38x squared o atong 0. Diri sa example number 2, tulo na nga to ang probability density function. So atong buhaton ana is kanang ato na sidyang murag i-integrate og lahi-lahi, then ang atong answer nga makuha is kanang na i-add silang duha, or pwede ra kung ingani ang inyong porma nga integral of x times x squared dx from 0 to 1 plus integral of x 2 minus x 1 to 2, limit of 1 to 2. So pwede rin nga na imo ra silang i-add. So karon after natong input sa to ang calculator, we would get a answer of 1. So kanang ang atong gamit ani nga kanang kanang unit bali is minute, naka-minute ani. So thus we expect a person will wait 1 minute of the elevator on average. So minute, no guys, kay dili ra man pud siguro moabot og dili ra pud siguro seconds, no, kay kana mo travel pa man natong elevator, dili ra pud oras kay tagbaw na sa kagumuwat ana. So figure 1 demonstrates the graphical representation of the expected value as a center of mass of the PDF. So pwede ra na nimo siya nga kanang naay graph pod. So as what you can see sa atong graph, the figure, the arrow represents the center of mass or the expected value of x. So di ba nakakuha man tag 1. So ang ana natin natungod ang ato ang mo na porma sa tong graph. Now now we calculate the variance and the standard deviation of x, no. So same as example 1 nga imo ra gyapon gamito to formula sa ato ang variance minus the squared value of your mean. So ito gyapon mo ra gyapon ang iyang concept, ang atong pag-input sa mga values nga i-integrate sila differently, then i-add sila ang ilang answer. So kani sa atong variance, kung pareha ning example is duha naman natin i-integrate, no, separately. So imo sa silang integrate, then i-add usa nimo i-minus sa imo nakuha nga mean. Kaya magsunod man gihapon ta sa ato ang kanang ay loss sa sign nga kanang nay maguna si plus sa minus. So after we input the values and solve it in the calculator, so makakuha ta og 1 over 6 nga variance, no, or equals to 0.167. So ato nang pangitaag square root ang ato ang 16, so makakuha tag 0.408 nga standard deviation. Gikan na sa tong variance nga 1 over 6. And that would be all sa mean and variance. So the next topic is normal distribution and would be presented and demonstrated by Miss Matuod.
So now we will talk about normal distribution. Undoubtedly, the most widely used model for the distribution of a random variable is a normal distribution. Whenever a random experiment is replicated, the random variable that equals the average or total result over the replicates tends to have a normal distribution as the number of replicates becomes large. Normal distribution, also known as the Gaussian distribution, is a probability distribution that is symmetric about the mean, showing the data near the mean are more frequent in occurrence than data far from the mean. In graphical form, the normal distribution appears as a bell curve. So now we will learn how to use normal distribution to calculate the probabilities with areas under the bell curve. This is what the bell curve looks like. As you can see beside the definition, that's what the bell curve looks like. Probability density function, or PDF. The role of probability density distribution is to be able to plot the bell curve. Given function of x is equals to 1 over sigma times square root of 2 pi times e to the power of 1/2 times x minus u over sigma squared, where x is the value of the variable or data being examined and function of x the probability function. U is the mean and sigma is the standard deviation.
Cumulative distribution function, or CDF. Its role is to calculate the probabilities. Given capital Fx is equals to integral of 1 over sigma times square root of 2 pi times e to the power of negative 1/2 times x minus u over sigma squared dx. So looking back at the bell curve, this has a vertical axis of symmetry which runs through the middle and passes through the x value that we call mean. Every bell curve has an equation which is given by the function in PDF. To solve for the probability, then we will use CDF. So if makaremember mo, CDF kay capital Fx is equals to integral of function of x dx. Then ang function of x nato ani ato ara i-substitute sa equation. So atong function of x man kay 1 over sigma times square root of 2 pi kato siya mao ang atong i-substitute, so makuha nato ang probability sa normal distribution. A normal distribution is defined in terms of its mean and standard deviation. The mean determines the peak that occurs, and the standard deviation determines how tall and spread out the curve is. The total area under a curve is always 1. Some useful results concerning a normal distribution are summarized below. Probabilities associated with a normal distribution. So kung magtan-aw ta sa ang graph, kaning graph sa atong unahon, naa na ang mean. Para makuha na to ang value, to the right kay u plus standard deviation, tas u sa ikaduha kay u plus ikaduhaon na standard deviation, tas u plus ikatuloon na standard deviation. Bali ang standard deviation amurag ang gap bitaw nila kada kuan, tas sa left pod kay mean minus na standard deviation, tas mean sa ikaduha kay to the left kay mean minus ikaduhaon na standard deviation, tas sa ikatulo kay mean minus ikatuloon na standard deviation. One standard deviation away from the mean to the left and mean to the right is 68%, as you can see here in the graph. Then, two standard deviation away from mean to the left and mean to the right is 95%. Then, three standard deviation away from mean to the left and mean to the right is 99.7%. We have example number 1. The test scores of a physics class with 800 students are distributed normally with a mean of 75 and a standard deviation of 7. What is the probability that a student chosen at random has a test score between 54 and 75? So, kung makita sa graph, if ato i-recall sa last slide, ginganito siya na pamaagi pero atong gikuha ang approximation niya by section. But to get the exact answer, we will use CDF in getting the probability of what was asked. So, ang gipangita kay probability between 54 and 75. So, makita na to sa graph kay naana ang 54 to 75. Ato na lang i-add up from 54 to 75 ang ilahang values na naa dire. So 2.14 plus 13.59 13.59 plus 34.33% kay is equals to 49.865%. In getting the exact answer, probability of 54 less than or equals to x less than or equals to 75 is integral of 1 over 7 times square root of 2 pi times e to the power of 1/2 times x minus 75 over 7 squared. Then, atuan ni siyang input sa atong calculator, then ang gawas ay naaday ang lower limit kay 54, then upper limit kay 75. Then kung atoon ning i-input sa atong calculator, ang answer kay 0.498650.102. So kung makita po nato ani ang nakuha nato sa approximation kay 49.865. So maora ni siya kung maora sila og answer, pero mas accurate ning sa gikuha ang probability gyud. Then so we'll discuss about standard normal distribution. Standard normal distribution is a normal probability distribution. A normal random variable with mean that is equals to 0 and standard deviation that is equals to 1 is called standard normal random variable and is denoted as z. Creating a random variable by this transformation is referred to as standardizing. The random variable z represents the distance of x from its mean in terms of standard deviations. It is the key step to calculate a probability for an arbitrary normal random variable. So, as we can see from this formula, this is what we will use to standardize the value of x. So, z is equals to x minus u over sigma. In getting the probability from a standard normal variable, suppose x is a normal random variable with mean u and variance sigma squared. Then, probability of x, capital X, less than or equals to small x is equals to probability of capital X minus u over sigma less than or equals to small x minus u over sigma is equals to probability of capital Z less than or equals to small z, where z is a standard normal random variable and z is equals to x minus u over sigma is the z value obtained by standardizing x. The probability is obtained by entering appendix table 2 with z is equals to x minus u over sigma. So after standardizing and getting the probability from a standard normal distribution, we need the z table. These probabilities are equivalent to the area under the curve to the left of the z-score. So ani na slide, this is the positive z-score. Ani na to pangitaon ang probability sa mga positive na values sa z. Then diri sa pika sa slide, mao ni ang negative z-score. Ani na to pangitaon ang mga probability na negative ang value sa z. And then, so next slide, we have example number 2. Your local pizza shop claims their large is at least 16 inches or it's free. Their pizza is normally distributed with a mean of 16.3 inches and a standard deviation of 0.2 inches. A. What's the probability of getting free pizza? Then B. What's the probability of getting pizza between 15.95 and 16.63 inches? So, we will first solve for the probability of getting free pizza. So, using the equation sa pag-standardize sa isa ka x value, z is equals to x minus u over sigma. So, substitute nato ang mga values. So, 16 minus 16.3 over 0.2 is equals to negative 0.3 over 0.2 is equals to negative 1.5. So, atong tanawon ni sa negative na z-score. Then, kung ato ang itunong ani sa left side, kay naa ang negative 1.5 man ang value sa atong z. Atong tanawon ang negative 1.5. Then, ang wala may nakasunod sa 0.5. So, 0. Ato ta sa 0 sa upper. So, ang value na naa kay 0.0668. So, mao na ang probability. Mao na ang probability sa 1.5. Then, probability, so, pag-define na to, probability of z less than negative 1.5 is equals to 0.0668. Then B, we will solve for the probability of getting pizza between 15.95 and 16.63 inches. Ato ang pangitaon ang z value aning duha ka buok ka given. So ato i-substitute, then we will have 15.95 minus 16.3 over 0.2 is equals to negative 0.35 over 0.2 is equals to negative 1.75. Then sa 16.63 minus 16.3 over 0.2 is equals to 0.33 over 0.2 is equals to 1.65. Then sa negative 1.75, ato ang tanawon ni siya sa z table. So, kung makita nimo sa kuan na ay nakabutang in z table, mo ni siya ang kuan value equivalent ania sa z table na 0.0401. Mo na siya ang probability sa 1.75. Then sa probability sa 1.65, mao ang 9.9505. Then sa papangita sa probability between nila, kay mahimo siyang probability of 15.95 less than x less than 16.63. Mahimo din ni siya sa tungkol sa pag-standardize, mahimo ni siya probability of negative 1.75 less than z less than 1.65 is equals to, ato ni siyang i-minus ning mas dako than sa gamay. So 0.9505 minus 0.0401. Then it is equals to 0.9105. So for the next topic, it will be discussed by Ms. Halil Bimission.
For our next topic, we are going to discuss about the normal approximation to the binomial distribution. So we learned that the normal distribution can be used as an approximation to a random variable with a large number of trials. Consequently, normal distribution can also be used to approximate binomial probabilities for cases which n is large. So before that, let's have a recap first about the binomial distribution. The binomial distribution is a discrete probability distribution used to find probabilities in which there are only two outcomes or can be reduced to two outcomes. For instance, flipping a coin can only have two outcomes, heads or tails. And on a test, a multiple choice question can be reduced to correct or incorrect. And real quick, there are 4 requirements for a binomial experiment. Number 1 is that there must be a fixed number of trials. Number 2 is that each trial can only have two outcomes or can be reduced to two outcomes, and this is often referred to as success or a failure. Number 3 is that the outcomes of each trial must be independent of one another. And number 4 is that the probability of a success must remain the same each trial. Binomial probability is the probability of x successes in n trials. For instance, if you toss a coin 3 times, what is the probability of getting exactly 2 heads? The binomial formula, or the formula for getting exactly x successes in n trials, is the probability of x equals n factorial divided by n minus x factorial times p to the x times q to the n minus x. In the formula, the probability of x is the probability of x successes. N equals the number of trials. P equals the probability of success in a trial. And Q equals the probability of failure in a single trial, which is 1 minus P. The mean equals N times P. And the standard deviation is the square root of N times P times Q. So if we calculate the problem, we see the result is 3 over 8 or 0.375, which is 37.5%. The issue with using this formula is that when n becomes large, the calculations can become very difficult. For instance, probability of 59 successes in 200 trials. We can see that the factorial computations are huge. This is where, under certain conditions, we can use the normal distribution as an approximation to calculate binomial probabilities. These conditions are: number 1, the problem must meet the 4 requirements of binomial distribution. Number 2 is that n times p must be greater than or equal to 5, and n times q must also be greater than or equal to 5. So for instance, if n, the number of trials, is 12 and p, the probability of successes, is 0.3, which equals to 3.6, a normal distribution should not be used as an approximation. And number 3, that if conditions 1 and 2 are met, a correction for continuity must be applied. And this means that for any value of x, we must use boundaries. For instance, the probability of 59 successes, which probability of x equals 59. In this case, we would use probability of 58.5 less than x less than 59.5. So 58.5 and 59.5 would be our boundaries. What is shown is the table listing the different probability scenarios of when to add or subtract 0.5. And we're going to go through several of these using examples. Let's say that a certain golfer lands his ball in the fairway 72% of the time using his driver. 3-part question. Number 1. What is the probability he hits 43 fairway drives in 54 total driver shots? Number 2. What is the probability he hits at most 39 fairway drives in 54 total driver shots? And number 3. What is the probability he hits more than 41 fairway drives in 54 total driver shots? In this situation, n, the number of trials equals 54. P, the probability of successes is 72% or 0.72. And Q equals 0.28, which is 1 minus P. The mean equals n times P, which is 54 times 0.72 equals 38.88. And the standard deviation is equal to the square root of n times P times Q, which is the square root of 54.0.72 times 0.28 equals 3.299. Before we do any calculations, we first need to make sure that the question meets the conditions to use a normal distribution as an approximation. It does meet the four requirements for a binomial experiment. N times P equals 38.88 and N times Q equals 15.12. So both of these are greater than or equal to 5. Since conditions 1 and 2 are met, we need to apply the correction for continuity for each of the three different questions. So for question 1, we are looking for the probability that x equals 43. And in the table, when x is equal to a value, we subtract 0.5 and add 0.5 to the value to get the boundaries. So on a normal distribution, we are looking for the probability of 42.5 less than x less than 43.5. For question 2, we are looking for the probability of at most 39. So 39 is included. We want the probability that x is less than or equal to 39. And in the table, when x is less than or equal to a value, we add 0.5 to the value to get the boundary. So on a normal distribution, we are looking for the probability of x less than 39.5. And for the question 3, we are looking for the probability of more than 41. So 41 is not included. We want the probability that x is greater than 41. And in the table, when x is more than a value, we add 0.5 to the value to get the boundary. So on a normal distribution, we are looking for the probability of x greater than 41.5. Now that we have our boundaries, we can calculate the probabilities, and we're gonna do this by taking their values and convert them to z-scores on a standard normal distribution, and use the z-score table to look up those probabilities. So for number 1, we want the probability of 42.5 less than x less than 43.5. We need to convert 42.5 and 43.5 to z-scores. The z formula is z equals x, or a value, minus the mean divided by the standard deviation. So for 42.5, we have z1 equals 1.09, and for 43.5, we have z2 equals 1.40. Looking this up to the z-score tables, for z1 of 1.09, we have 0.8621 to the left of the line, and for z2 of 1.40, we get 0.9192 to the left of the z-score. To find the probability between these values, we'll subtract z1 from z2. 0.9192 minus 0.8621, which equals to 0.057 or 5.7%. So there's a probability of 5.7% that the golfer hits 43 of the 54 drives in the fairway. Now for question 2, we want the probability of x less than 39.5. Again, we first convert 39.5 into a z-score, which calculates out to z equals 0.19. Using the z-score table, we get 0.5753 to the left of the z-score, and this is the probability. So there's a 57.53 probability that the golfer hits at most 39 of 54 drives in the fairway. Lastly, for question 3, we want the probability of x greater than 41.5. Again, convert it to a z-score, which calculates out to z equals 0.79. Using the z-score table, we get 0.7852 to the left of the z-score. But we want the probability greater than to the right of the line. Since we know that the total area under the curve is equal to 1, we can subtract 0.7852 from 1, which equals to 0.2148 or 21.48%. So there's a probability of 21.48% that the golfer hits more than 41 of 54 drives in the fairway. For our next topic, it will be discussed by Miss Divine Kalibugan.
Normal approximation to the Poisson distribution. We have learned that normal distribution can be used to approximate binomial probabilities for cases when n is large. And in Poisson distribution, we can also apply it in solving larger number. So first, let us have a recap about a Poisson distribution. So Poisson distribution is a probability distribution that describes the number of events occurring within a fixed interval of time or space. It is typically employed in situations where rare events are observed, such as the customer arrival in a minute or the number of accidents at an intersection. The Poisson distribution formula is equals to lambda to the power of x times e to the power of negative lambda over the x factorial, where x is the counting numbers 1, 2, 3, and so on, and the lambda represents the mean number of occurrences in the interval, and the e, the Euler's constant, which is approximately equal to 2.71828. Now, let's discuss when we can use the normal approximation. Normal approximation is a technique used to estimate Poisson probabilities under specific conditions. It is typically employed when the average rate or the mean is relatively large, that the lambda is greater than 20. Then to use the normal approximation, we need to understand the formula, that the mean and variance of a Poisson distribution are approximately equal. Therefore, the parameters of the approximating distribution will be the mean equals lambda, the variance is equals to lambda, the standard deviation is equals to square root of lambda. Then additionally, we'll find the g-score using the formula g is equals to x minus lambda over square root of x. So we should have to take note that changing discrete distribution to continuous distribution requires continuity correction factor. It is an addition or subtraction of 0.5 to the x value. So to illustrate this concept, let's work through an example problem. The average number of calls received by a hotel receptionist is 6 per hour. Find the probability of receiving A, less than 17 calls in 4 hours, B, more than 31 calls in 6 hours. So given lambda is equals to 6 calls per hour. So let us define that the variable x as the variable of interest, which is a number of calls received. Then the Poisson distribution is mean is equals to 6. So referring to question A, the interval has been changed to 4 hours. So for 4 hours interval, lambda is equal to 24. So 6 times 4 is equals to 24. Now, we have a Poisson distribution greater than 20. Thus, this Poisson distribution can be approximated to normal distribution with mean equals 24, variance equals 24. Since the variance is equal to 24, the standard deviation is equals to 4.899. So the probability of receiving less than 17 calls in 4 hours is probability of x less than 17 because we changed the Poisson distribution to normal distribution, so we must apply the continuity correction factor to the probability that we want to find. So the probability that we want to find now becomes x less than 16.5 because of using the continuity correction factor. So to find the probability of x less than 16.5, let us find the g-score for our example. That involves using the formula of x minus lambda over the square root of lambda. So we should plug in our x is 16.5 minus lambda, the 24, over 4.8999, the square root of lambda. So we get the probability of g less than negative 1.53. So after that, we should have a bell-shaped graph with 0 at the center. Then plot negative 1.3, negative 1.53. Then the region of probability depends on inequality sign because we want to find probability of z less than negative 1.53. So the region would be to the left of negative 1.53. So to find the probability of z less than negative 1.53, we should change the probability of z greater than positive 1.53 and then look this value to the probability of table. So we got 0.0630. So the probability of x less than 17 is approximately equal to 0.0630. So in question B, the interval has been changed to 6 hours. So 6 times 6 is equals to 36. So now that we have a Poisson distribution greater than 20, thus the Poisson can be approximated to normal distribution with mean equals 36, variance is equals to 36, and the standard deviation is equivalent of 6. So the probability of receiving more than 31 calls in 6 hours is probability of x greater than 31. Then, because we have changed the Poisson distribution to normal distribution, we must apply the continuity correction factor to the probability that we want to find. So the probability of x greater than 31 will becomes x greater than 31.5. Next, find the probability of x greater than 31.5 by using the g-score by using the formula x minus lambda over square root of lambda. So plug in 31.5 minus 36 over 6, that is equivalent of negative 0.75. So after that, we have to use a bell-shaped graph with 0 at the center, then plot negative 0.75. Then the region of the probability depends an inequality sign because we want to find the probability of z greater than negative 0.75. So we need to change the probability to the probability of z less than positive and take 1 minus the probability of z greater than the positive 0.75, which when we look to the table, we got 0.2266. So 1 minus 0.2266 is equivalent of 0.7734. So example number 2. In a particular factory, the number of accidents occurring in a month follows a Poisson distribution with a mean of 2. Find the probability that there will be at least 22 accidents in a year. So let us define the variable x as the number of accidents occurring in a year where the mean is 24. So it is 24 because there's a mean rate of 2 accidents per month. Then over a year, there are 12 months, so there will be going 2 times 12, so it equals to 24 accidents. So now that we have a Poisson distribution greater than 20, thus this Poisson distribution can be approximated to the normal distribution with mean equals 24, variance is equals to 24, and the standard deviation is equal to 4.899. So the probability of there will be at least 22 accidents in a year is the probability of x greater than or equal to 22. Because we have changed the Poisson distribution to normal distribution, we must apply continuity correction factor to the probability that we want to find. So the probability that we want to find now becomes x is greater than 21.5. Why not 22.5? We can also consider the area to the right of 22 to be 22.5. But because we should include 22, the area carries on up to the left side. So next, to find the probability of x greater than 21.5, let us find the z-score for our example. That involves using the formula x minus lambda over square root of lambda. Then let us plug in. X is 21.5 minus lambda 24 over 4.899. So we get negative 0.5103. So if you are working on the probability of z being greater than a negative number, you have to reverse this round to have access to the table. So we need to change the probability of z less than 0.5103. Then look this value up in the z tables. So we got 0.6950. So the probability of x greater than or equal to 22 is equivalent of 0.6950. And for the next topic, it will be discussed by Miss Denesa Tero.
Now I will introduce to you this continuous uniform distribution. So continuous uniform distribution is also referred to as a rectangular distribution. It is the simplest probability distribution in statistics. Still, it plays an important role since it is instrumental in modeling random variables. It is concerned with the events that are equally likely to occur. It is a continuous distribution, which means that it takes values within a specified range. Example given between 0 and 1. So probability density function. The probability density function for a uniform distribution taking values in a range a to b is f of x equals to 1 over b minus a. And a is the minimum value, b is the maximum value. Shown here is the graph of the continuous uniform probability density function. Creating a graph for a continuous uniform probability density function is essential for enhancing our understanding and visualizing the probability distribution. This graphical representation will help us better grasp the specific area where we intend to calculate the probability. The cumulative distribution function of a continuous uniform random variable is obtained by integration. If A is less than x but not greater than p. So f of x, the big f of x, represents the cumulative distribution function. As discussed earlier, the cumulative distribution function is derived by integrating the probability density function of the continuous uniform distribution. So the cumulative distribution function of the uniform distribution is f of x is equals to integral of 1 over b minus a du equals to x over b minus a over b minus a. Therefore, the complete description of the cumulative distribution function of a continuous uniform random variable is f of x equals to 0 if x is less than a. F of x is equals to x minus a over b minus a if a is less than x and x is less than b. And f of x is equals to 1 if b is less than x. So calculating probabilities. Remember, we can calculate probabilities using integration from any continuous probability density function. So the probability of C less than or equal to x, or x is less than or equal to d, is equal to the integral of f of x dx equals to 1 over b minus a. So 1 over b minus a is the PDF of the uniform distribution. So i-manay substitute sa f of x and lower limit c at upper limit d, dx equals to d minus c over b minus a. So to calculate probabilities, probability of c less than or equal to x and x is less than or equal to d is equals to d minus c over b minus a. However, this is essentially equivalent to the cumulative distribution function. So the mean of the continuous uniform random variable x is e of x is equals to integral of x minus over b minus a dx is equals to b plus a over 2. So the variance of x is e of x, or variance x equals to the expected value x squared minus the e squared of x equals to the integral of x squared over b minus a dx minus the b minus a squared over 12 is equals to b minus a squared over 12. These results are summarized as follows. Now, let's consider an example where we can apply these formulas. Let the continuous random variable x denote the current measured in a thin copper wire in milliamperes. Assume that the range of x is 0 to 20 milliamperes, and assume that the probability density function of x is f of x equals to 0.05, where 0 less than or equal to x but not greater than or equal to 20. What is the probability that a measurement of current is between 5 and 10 milliamperes? The requested probability is shown as the shaded area in the figure. So as you can see in the figure, the f of x is equals to 0.5 and the x is 0 to 20. So that is the total area. Ang gipangayo is between 5 and 10. So we will have this probability of 5 less than 2x but not greater than 10 is equals to the integral of f of x dx from a lower limit 5 and upper limit 10. So substitute the value of f of x and we will have this answer 0.25. Another way of solving this is probability of 5 less than x but not greater than 10 is equals to d minus c over b minus a. So kung nakainomdom mo, ang kani nga formula is the cumulative distribution of the uniform distribution. So we can we can use the CDF formula for us to come up with the probability requested in this problem. So we have that value of D equals 10 and the value of C is 5 and our B is the maximum value 20 and A is the minimum value 0 given in the problem. So 10 minus 5 over 20 minus 0 is 5 over 20 and that will be 0.25. To solve the mean and variance, formulas can be applied with A is equals 0 and B equals 20. So mu is equals to B plus A over 2. So this is the formula of mean and substitute the values. B equals 20 and A equals 0. So mu is equals 20 plus 0 over 2. We will have an answer of 10 milliamperes. So our mean is 10 milliamperes and the variance is sigma squared equals b minus a squared over 12. So substitute the values. We will have this 20 squared over 12. We'll have an answer of 33.33 milliamperes. So to get the standard deviation, we will just have to square root the value of the variance. So square root of 33.33 is equals to 5.77. Therefore, E of x is equals to 10 milliamperes and our variance is equals to 33.33 milliamperes and consequently, standard deviation of x is 5.77 milliamperes. That is all about the uniform distribution. So moving forward, let's explore the exponential distribution in the context of continuous probability, where this is closely related to the Poisson distribution or the Poisson process. So exponential distribution. The exponential distribution is often concerned with the amount of time until some specific event occurs. It is a process in which events happen continuously and independently at a constant average rate. The exponential distribution has the key property of being memoryless. The exponential random variable can either more small values or fewer larger values. So exponential distributions are commonly used in calculations of product reliability or the length of time a product lasts. So as shown in the figure, that is the graph or the probability of for the exponential distribution. So same as the uniform distribution, the x-axis will be the continuous variable x and the y-axis is the function of x or the PDF, probability density function. So, difference between Poisson distribution and exponential distribution. The Poisson distribution gives the probabilities for the number of events taking place in the given time period, whereas the exponential distribution gives the probabilities for times between the events. Both of these concern events occurring randomly in time at a constant average rate with a symbol lambda. So we will further differentiate pag yun ng exponential and Poisson. And sa exponential, the question is how much time between the given events. While in the Poisson, how many events occur in time interval. And in the exponential, that is mostly asking for the number of time. So that is considered as continuous. And in the Poisson, that is the number of events. And the Poisson is a discrete probability distribution because it is finite. And the symbol lambda in exponential, it is the rate of occurrence. And in the Poisson, the lambda is the expected number of occurrences. So that's the kalahian or the difference between the two distribution. And so much for that. The random variable x that equals the distance between successive counts of a Poisson process with mean lambda greater than 0 is an exponential random variable with parameter lambda. The probability density function of x is f of x equals to lambda exponential negative lambda x if 0 is less than or equal to x and x is less than or equal to infinity. In Poisson distribution, x represents the discrete number of events, while in exponential distribution, x represents a continuous interval. So lambda represents the rate distribution or the rate parameter. And lambda could be get or makuha siya through events over time or 1 over time. So therefore, the cumulative distribution function of x in the exponential distribution will have a 1 minus exponential negative lambda x. So the f of x equals probability of x less than or equal to x. Small x is equals to 1 minus e raised to the power of negative lambda x when x is greater than or equal to 0 is the cumulative distribution function of x. So the big f of x, sana giingon nga ang dako nga f of x is the cumulative distribution function. So ang f of x of exponential distribution is 1 minus e negative lambda x. And when dealing with a situation where we want to find the probability that a random variable x is greater than or equal to a specific value x, we can utilize the cumulative distribution function CDF to derive a formula for this probability. So probability of x greater than or equal to the small x will have equals to 1 minus f of x. We will use that to come up the IA or to derive a formula for the probability nga ang big X or the continuous variable will be greater than or equal to the small x. So we will use this exponential raised to the power of negative lambda x if x or the big X is greater than the small x. So the mean and variance of exponential distribution. The mean of the exponential distribution is calculated using the integration by parts. Hence, the mean and variance of the exponential distribution are shown below. So mean equals or mu is equals to the expected value equals to 1 over lambda. And variance or the sigma squared is equals to Vx equals to 1 over lambda squared. And the standard deviation of an exponential distribution is the square root of its variance or just equal to the mean. Sigma equals to the square root of 1 over lambda squared or that is equals to the mean. So let's have now an example. Laptop produced by company XYZ lasts an average for 5 years. The lifespan of each laptop follows an exponential distribution. So first, we will calculate the rate parameter or we will get the value of lambda. Second is write the probability density function and graph it. Third is what is the probability that a laptop will last less than 3 years. Fourth is what is the probability that a laptop will last more than 10 years. And fifth is what is the probability that a laptop will last between 4 and 7 years. So we will have this, in calculating the rate parameter, there is a given time, 5 years, or the average of 5 years. So lambda equals 1 over the time 5 years, have an answer of 0.20 years. So that is our value of lambda. And second is to get the probability density function of an exponential distribution. We will use this formula lambda e raised to the power of negative lambda x, and we will substitute the value of lambda 0.20. So we'll just substitute it to the formula 0.20 e raised to the power of negative 20 x. So that is our probability density function, and we will have to graph it. So the figure or the image attached here is the probability density function, or the graph of the probability density function. So as shown, the f of x is equals to 0.20, and we have the continuous variable x in the x-axis. Third question is, what is the probability that a laptop will last less than 3 years? So the probability of x, big X, less than the small x is equals to, since it was said na it will last less than 3 years man, so the continuous variable will be less than x, equals 1 minus e negative lambda x. So this is just like in the uniform distribution. To get the probabilities, we will always use the formula of cumulative distribution. So the formula of the cumulative distribution of exponential distribution is equals to 1 minus e raised to the power of negative lambda x. So we will substitute the value of lambda and the x. So we have the value of lambda 0.20 and the value of x is 3. So substitute the values. 1 minus e raised to the power of negative 0.20 times 3 is equals to 0.45118883639, or in percentage you will have 45.12%. And the fourth question, what is the probability that a laptop will last more than 10 years? So more than siya. So probability of x more than, or greater than x is equals to e raised to the power of negative lambda x, since greater than naman ang the continuous variable. The value of lambda is still 0.20 and the value of x now is 10. So we will substitute the values and we will have the answer of 0.1353352832, or in percentage it is 13.53%. So last is, what is the probability that a laptop will last between 4 and 7 years? So now we have this probability of 4 less than x and x is less than 7. So what we're going to do here is i-separate silang duha to get atong kon ang probability nga ang x is less than 7 i-minus sa probability nga ang x less than 4, and we will use the cumulative distribution function, the CDF of exponential distribution, tong 1 minus e raised to the power of negative lambda x. So the value of lambda is still 0.20 and our x is first is 7. So 1 minus e raised to the power of negative 0.2 multiplied 7 is minus sa probability of x less than 4. Sila to gapong gamitan ang gamiton ang formula nga CDF 1 minus e raised to the power of 0.2, then ang x niya is 4. Then I subtract, then the difference will be 0.2027, or in percent that is 20.27%. And that would be all about the exponential distribution. As summary of this topic, random variables, whether discrete or continuous, are a key concept in statistics and experimentation because they are random with unknown exact values, and this allows us to understand the probability distribution of these values, of those values, or the relative likelihood of certain events. And that would be all. Thank you, everyone.